Hello everyone, welcome to the another lecture of alcohol, phenols and ethers. Myself Suman Singh. So in the last class we have discussed about the preparation of alcohol. So in today's class we will discuss about the phenol. Okay, so we will discuss about phenol. Okay, so phenol is what? Phenol are hydroxyl derivatives of aromatic hydrocarbons. Okay, in which the hydroxyl group, which is the OH group, okay, is directly attached to the carbon atom of the aromatic ring. Okay, carbon atom of the aromatic ring. Or we can also define like this, that the when OH group is attached to a benzene ring, when suppose this is our benzene ring, and when OH group is attached to this benzene ring, so at that time the compound which is formed is known as phenol. Okay, the compound which is known as the compound which is formed is known as phenol. So I hope you have got some idea about phenols, right? Now, like alcohol, phenols also may be classified as monohydric, dihydric, trihydric, or polyhydric, okay, according to their molecules containing 1, 2, 3, or more hydroxyl group respectively. Okay, now dihydroxy derivative of benzene are also known as 1,2 or 1,3 or 1,4 1,3 1,2 or 1,4 benzene diol. Okay, these compounds are popularly known by its common name. So regarding common name, when we will talk about a common name in IOPS name, so we will see first what is the rule for IOPS name and common name. Okay, using meta, at that time we can use 1 or 3, and when we are using a para, so at that time 1 and 4. Okay, but however some substituent phenols are still popularly known by its tribal name. Okay, so one by one we will see this. Now again, for our system for IUPAC, what we can say that the IUPAC system, in IUPAC system all the substituted phenols are named as derivatives of phenol, and the position of the substituent with respect to OH is indicated by a numerical, okay, Arabic numericals, with the carbon carrying OH group being numbered as 1, right? So we will see one by one the example. So first example is, suppose this one, suppose OH is here and here is CH3. So what is the name of this compound? Its compound name is ortho CRESOL. Okay, orthocresol, or we can also write 2 methyl, okay, 2 methyl phenol, 2 methyl phenol, right? So this is IOPS name and this is common name. Now next, one more example we can say. You can take one more example. Suppose we have this OH is here, and suppose here is CH3. So what is the name? Its name is paracresol, CRESOL. Okay, or we can write that 4 1 2 3 and 4. Okay, so 4 methyl phenol, or methyl phenol, right? Now next, if it is like this, suppose if it is like this, here is OH and another one here is also OH. So what is the name? Its name is catechol, CATECHOL. Okay, and when we talk about the IUPAC name, its name will be 1 2 3 4 3 4 5 6. So at that time name will be benzene, benzene, according to the new system. Okay, 1 2 diol. Okay, diol, right? Now next, one more example we can say. Suppose this is Another example, here is OH and here is again OH. So this is called what? This is a quinol. Okay, there is a QUINOL. Okay, quinol. Or we can also write the IOPC name will be benzene 1,4 diol. Okay, now next one more example we can see. If you are taking the example of suppose there are three hydroxy groups, suppose like this, one is here OH, another one is here OH, and next one is here OH. So at that time what will be the name? Its name will be hydroxy, HYDROXY, hydroxy quinol, QUINOL. Okay, and when we talk about the IUPAC name, it will be BENZENE, benzene 1 2 3 4 5 6, right? Benzene 1 2 4 triol, right? So I hope you have got the ideas about nomenclature. Okay, two more example I will give you. One is suppose this. Okay, suppose this is one example. Here OH is there, so what will be the name? Its name will be alpha naphthol, NAPTHOL. And when we talk about the IOPC name, it will be 1-naphthol, NAPTHOL. Okay, so I hope you have got some idea about the nomenclature. Okay, so now we will see the preparation of phenol. Okay, from chlorobenzene. So when we talk about the chlorobenzene, or this is also called DOWS, DOS process. Okay, DOS process or chlorobenzene. Okay, now what is this process? So this phenol is manufactured here in this process. Phenol is manufactured by heating chlorobenzene with 10% aqueous sodium hydroxide solution for about 623 Kelvin under 300 atmospheric pressure. Okay, in the presence of copper salt, where copper salt is acting as a catalyst to form sodium phenoxide. After the formation of sodium phenoxide, the sodium salt, when treated with this HCl, we will get phenol. Okay, and this process is also called Dow process. So what is happening in this process? The first process, in the first process, there will be a suppose we have a chlorobenzene here, we have a chlorobenzene here. Okay, this will be reacted with 2NaOH in presence of suppose 623 Kelvin. Okay, or 300 atm in presence of copper salt, or we can say that NaCl or H2O. We will get what? Sodium phenoxide, which is like this. We will get here sodium phenoxide, ONA. Okay, now this sodium phenoxide is further treated with HCl. Okay, or NaCl will come out from here, or NaCl. So it will give what? It will give phenol. Okay, it will give phenol. It will give phenol. OH. I hope you have understood this, right? How to prepare this phenol from chlorobenzene, right? Now next process is from benzene sulfonic acid. Okay, so when we talk about the benzene sulfonic acid, here we are using oleum, OLIUM. Here we are using oleum. So oleum is what? It is a mixture of H2SO4, okay, and SO3. It is a mixture of H2SO4 and SO3, which will form H2S2O7. Okay, so we are using this oleum. Oleum is basically, this one is a oleum. Okay, so in this reaction, what is happening here? Benzene is sulfonated with oleum, which is S2S2O7 in, and the benzene sulfonic acid will form. Okay, the benzene sulfonic acid so formed is then converted to a sodium phenoxide on heating with a molten sodium hydroxide. Now the further the acidification will give phenol. Okay, so we will see what is happening here. In the first case, what will happen? In the first case, there will be, suppose a benzene is here, we have a benzene here. Okay, and this benzene is sulfonic is heated with that H2S2O7 H2S2O7. Okay, so it will give what? Benzene sulfonic acid. It will give what? Benzene sulfonic acid. Okay, it will give benzene sulfonic acid SO3H. Okay, which is further, this is what? Benzene sulfonic acid. Okay, this is benzene sulfonic acid, which is further treated with NaOH. In H2O will come out from here, H2 H2O will come out from here. After that, it will give what? Sodium benzene sulfonate. It will give what? I am writing here, sodium benzene sulfonate, which is like this, SO3Na. Okay, which is further fused with NaOH to give sodium phenoxide. Okay, under high pressure it will give what? It will give sodium phenoxide in presence of NaOH. So it will give here sodium phenoxide like this, ONA, which is further treated with HCl. Okay, HCl and presence NaCl will come out. It will give what? Phenol. Okay, so in this way we used to prepare phenol from benzene sulfonic acid. Okay, so I hope you have understood this, right? Now next we will see from a very important topic, which is from Grignard reagent. So when we talk about from diazonium salt. Okay, after that Grignard reagent, from diazonium salt. So when we talk about the preparation from diazonium salt, so here we are using HONO. Okay, so HONO will not or we can say HNO2 we are using here. So HNO2, how we are preparing? First of all, we will see how HNO2 we are getting, because HNO2 is we will not get in a native state. Okay, so what we will do, we will, for to get HNO2, what we will do, we will first use here NaNO2. We are talking about diazonium salt. Okay, preparation from diazonium salt. So we will take here NaNO2, when it will be heated with HCl, when it will react with HCl at around 0 to 5 degrees Celsius. Okay, 0 to 5 degrees Celsius, it will form HNO2. Okay, now this one we will use in the reactant. Okay, so here what is happening, suppose we have any aryl group here and it is attached to, suppose, NH2. So what will happen at that time, if we are using here HONO? Okay, so it will form where ArN2 plus. Okay, which is further treated with Cu2O or Cu2 plus to give ArOH. Okay, so in this way we prepared from diazonium salt. Okay, here rate, when we talk about the rate, so rate will depend on the electron withdrawing group. Okay, so one more example I will give you, that will make you more clear about this. Suppose directly we are using here benzene diazonium chloride. Suppose if we are taking here benzene diazonium chloride, suppose we are using here benzene diazonium chloride N2 plus and Cl minus. Okay, at that time, if we are treating this with H2O, so it will give directly, and if we are treating with H2O and warm, it will give phenol. Okay, it will give phenol, and N2 and HCl will come out from the reaction. Okay, so I hope you have understood this. the preparation of a phenol from diazonium salt, right? Now next is very important, which is from cumin, Cumene. It is very important for your exam point of view, right? Very very important. Okay, so we will see this. So when we talk about the from cumin, here phenol is commercially prepared with this method. Okay, here phenol is prepared commercially with this cumin, which is also called isopropyl benzene. Okay, and this cumin is prepared by Friedel-Crafts alkylation of benzene with propene in presence of phosphoric acid at 523 Kelvin. Okay, first of all we will see the preparation of cumin, and after the preparation of cumin, when you will see that after we got the cumin, after that we will see how we will prepare cumin, from cumin how we will prepare phenol. Okay, so first of all when we will see preparation of cumin, so to see the preparation of cumin is very easy. We can prepare like this. Suppose we are using here benzene. Okay, benzene we are using here, and benzene we are using here. If it is reacting with this, suppose, okay, in presence of H3PO4, okay, at around 250 degrees Celsius, under high pressure, it will give cumin. Cumin structure is like this. It will give cumin, which is like this. Okay, this is the cumin. Okay, Cumene, cumin. Now we have got for how we have prepared, right? There are so many methods to prepare cumin. One more method I will show you. Suppose we have here benzene. Okay, and in presence of AlCl3, or if we are using this Cl here, Cl is, this is Cl, right? If we are using Cl, then also we will get here cumin like this. We'll get cumin. One more method is there. If we are using in benzene, if we are supplying here, suppose this Cl, and in presence of FeCl3, sorry, in presence of FeCl3, it will again give cumin. Okay, in this benzene we are using, it will again give cumin like this. So there are so many methods to prepare cumin. Now after the formation of cumin, we have got cumin here, right? So now we will see how to prepare from cumin, how we will prepare phenol. Okay, so let's see here. Suppose there is a cumin here. I will write in a full form, right? CH3 CH CH3. Okay, CH3. Here there is a cumin here, our cumin. Okay, this will be oxidized first. O2, in presence of O2 it will be oxidized. So when you will oxidize this, it will form cumin hydroperoxide. Okay, what it will form? It will form cumin hydroperoxide like this. It will form cumin hydroperoxide like this. Sorry, there's only a single line here. Carbon COOH. Okay, COOH, here CH3, and here again CH3. Okay, so this is what this is, cumin hydrophenoxide. Okay, now again what we will do, we will pass here in presence of H plus or H2O, it will give what? Phenol. Okay, it will give here phenol, which is OH, and the byproduct will be propanoate, or we can say acetone. Acetone will be the byproduct here, which can be written as like this. Acetone will be the byproduct. Okay, this will be the byproduct. So I hope you have understood how to prepare cumin, and after that from cumin how to prepare phenol, right? Nothing is there, but first we have to oxidize. After the oxidation we will get this. What is this? Cumin hydroperoxide, and after that in presence of H2O, H positive and H2O, we will get phenol, and the byproduct will be acetone, right? So I hope you have understood this. Okay, so one more time, let me draw here like this. Suppose this is our cumin here. Suppose this is our cumin, O-OH. Okay, in presence of H3O positive at around 50 to 90 degrees Celsius, we will get phenol here, OH, and bright product will be, byproduct will be acetone O, right? So I hope you have understood this. So this was all about the preparation of phenol. So in the next class we will discuss about the properties, physical and chemical properties of phenol. Okay, till that, thank you.